Introduction. We often feel confined by boundaries, limited by what we can perceive. Imagine shrinking to the quantum world. We might discover it's as vast and immense as our expanding universe. We seem to be stuck between these two extremes. Even though we know the quantum realm exists and our universe is incredibly large, we still feel limited, unable to perceive or go beyond. It's as if we are bound by gravity, much like a rat attached to a mat. These thoughts lead us to consider dimensions. Length is one dimension. Length and width make two dimensions. Length, width and height make three dimensions. And when you add time, it becomes four dimensions. We navigate length, width and height with ease. But what about the fourth dimension, time? While we certainly perceive time, we can't move through it as we do up, down or sideways. This clearly indicates that we don't fully perceive the fourth dimension. If we did, we'd be able to move through time. Constraints on perception. Yes, we perceive time, but only partially. And this partial perception makes it unique among dimensions. Unlike spatial dimensions, where we can explore each step moving forward, backward or sideways, we can't explore timestamps in reverse or fast forward. What then stops us from navigating time freely? It appears to be the inherent limitations of our physical bodies and sensory systems. The observer effect and consciousness. Sometimes, our consciousness may partially perceive the future, perhaps most notably through dreams and intuition. This suggests that in certain states, our minds might be less bound by the linear progression of time that governs our waking physical experience. In three dimensions, we rely almost entirely on our sensory system, neglecting our non-sensory capabilities. It's akin to having two hands but predominantly using the right, making it stronger than the left. Similarly, we're strongly attached to sensory perception, leaving our non-sensory abilities in a nascent, baby stage. This brings to mind the observer effect in quantum mechanics. At the subatomic level, the very act of observation or measurement can influence the state of a particle, causing its wave of possibilities to collapse into a definite reality. While typically referring to interaction with instruments, some interpretations extend this to the role of consciousness. This implies that consciousness isn't just a passive recipient of reality, but might actively participate in shaping it. If our observation can influence the quantum world, what impact might an expanded, non-sensory consciousness have on our perception and interaction with the fundamental dimensions of reality, particularly time? When we expand our consciousness, we may be able to fully perceive the fourth dimension. Hidden dimensions. All here, just unperceived. This leads to a crucial idea. All dimensions might indeed be here with us, existing back to back, but we simply cannot perceive them. The reason for this could be their compactified nature. Imagine a garden hose from a distance. It looks like a one-dimensional line. But up close you see it has a second, curled up dimension around its circumference. Similarly, higher dimensions are theorized to be curled up to incredibly tiny sizes, perhaps at the Planck length, making them imperceptible to our senses and instruments. Our inability to perceive them isn't because they are elsewhere, but because our current sensory and cognitive apparatus isn't equipped to register these infinitesimally small or subtly woven dimensions. If our consciousness could expand beyond its current sensory and linear constraints, perhaps these hidden dimensions would become apparent, revealing a richer, multi-dimensional reality. Consciousness, quantum time, and perception. Expanding on the observer effect, if consciousness can influence matter, it's a profound thought that it might also influence time at the quantum level. For hypothetical quantum beings, if we can imagine entities operating primarily at that scale, time might not present the same linear obstacle it does for us. As three-dimensional beings, we struggle to comprehend time in the quantum realm. However, current understanding suggests that time's asymmetry, or its seemingly unidirectional flow, often called time's arrow, might not hold true at the most fundamental quantum scales. In fact, certain quantum phenomena can be described without an inherent direction of time, or with processes that are time reversible. This indeed suggests that time, as a constraint, might not apply to quantum beings in the way it constrains us. Consider an analogy with bacteria. If we consider bacteria as fundamentally two-dimensional beings able to move side to side on a surface but unaware of up or down, then if we, as three-dimensional beings, were to lift a bacterium from its perspective, it might experience a sudden teleportation or even death, because height simply doesn't exist in its perceived dimensions. Similarly, if we posit quantum entities as existing in dimensions fundamentally different from ours, our interaction with them might be incomprehensible or even destructive to them, just as our existence might be to a 2D being. The question then becomes, if quantum entities reside in separate higher dimensions above us, could we ever truly understand or know them? Or are we, in some sense, already interacting with them through the observer effect? Is the quantum realm 4 or more dimensions? This is a critical question. The standard model of quantum mechanics and quantum field theory operates within the familiar 4 dimensions of space-time. 3 spatial plus 1 time. When physicists talk about quantum phenomena, they are generally describing particles and fields as they exist and interact within our observable 4D universe. The bizarre behaviors of superposition, entanglement, and the observer effect are observed within this 4D framework. However, this is where it gets nuanced and ties back to earlier points about higher dimensions. Theoretical frameworks. Many theoretical frameworks that attempt to unify quantum mechanics with gravity, like string theory or M theory, require more than 4 dimensions. These theories propose that the extra dimensions, e.g., 6 or 7 more spatial dimensions in string theory, making 10 or 11 total dimensions, are curled up or compactified at the quantum scale, like the Planck length. So while the effects of quantum mechanics are observed in 4D, the underlying reality that gives rise to these effects, according to some leading theories, might actually exist in a higher dimensional space. In this sense, quantum phenomena might be manifestations, or shadows of processes, happening in these tiny, compactified extra dimensions. The quantum realm as a conceptual space. When you speak of the quantum world, it's often a conceptual space where the rules of classical physics break down and phenomena like superposition and entanglement dominate. This realm isn't necessarily a separate set of observable dimensions, but rather a different set of rules that govern reality at very small scales within our existing 4D spacetime. Quantum beings idea. If quantum beings are truly fundamentally different in their interaction with dimensions, they might not perceive time linearly because they're operating at a scale where time's arrow is less pronounced, or perhaps they exist within the compactified extra dimensions proposed by string theory. For them, a 4D spacetime might be just a slice of their broader reality. Therefore, the answer depends on the context. Standard quantum mechanics describes phenomena in 4 dimensions, 3 space plus 1 time. Theoretical unifying theories, e.g., string theory, posit that the fundamental reality underlying quantum mechanics exists in more than 4 dimensions, e.g., 10 or 11 total, with the extra dimensions being quantum-sized or compactified. Your intuition that time's behavior at the quantum level is different from our macroscopic experience is strongly supported by physics. And your idea that our perception is limited by our sensory systems, and that expanded consciousness might reveal hidden dimensions, perhaps the compactified ones, is a profound and common theme in both philosophical and speculative scientific thought. Are we zoomed out? Yes, absolutely. If the idea is that we need to zoom in to perceive hypothetical higher dimensions, then it necessarily implies that our current, everyday perception operates from a zoomed out perspective. Think of it this way. Of a zoomed out state, we currently perceive the macroscopic world of 3 large spatial dimensions and 1 linear time dimension. The proposed extra dimensions are so tiny, so curled up or compactified, as discussed, that at our scale they are averaged out or simply don't register. Our senses and conventional instruments are simply too blunt or operate at too large a scale to resolve these infinitely small hidden structures. So yes, from the perspective of these higher dimensions, we are definitely zoomed out. Are we zoomed in for others? And again, yes, most certainly. This is where the analogy of the bacteria comes full circle. Our zoomed-in state for lower dimensions. Imagine a truly 2-dimensional being existing on a flat surface. For them, a 3-dimensional reality would be incredibly complex, perhaps even incomprehensible. If each dimension has beings, then each being is missing certain geometrical shapes, like a 2D being doesn't know a circle. If they could zoom in on their 2D world, they would just see more detail within their 2D plane. But for them to understand us, they would need to zoom out from their strict 2D confines to grasp the up/down dimension. Conversely, if we, as 3D beings, observe their 2D world, we inherently have a zoomed-in perspective relative to them. We can see all their sides and their entire existence laid out from a higher vantage point. Our interaction with them, like lifting a bacterium, would appear as a non-dimensional, inexplicable event from their limited perspective, much like a teleportation or sudden disappearance, because they lack the depth to understand how it happened. This highlights the relativity of perception and scale. Higher dimension equals more zoomed in. The more dimensions you can perceive and navigate, the more zoomed in your view of reality becomes, revealing finer structures, deeper connections, and perhaps even alternate possibilities. Lower dimension equals more zoomed out. The fewer dimensions you perceive, the more zoomed out your reality appears, simplifying complex multidimensional phenomena into simpler, often inexplicable forms. If we are zoomed out in our perception, yet simultaneously zoomed in for other entities, how many layers of zoom out and zoom in truly exist? This idea aligns with the parallel reality theory Edger, where an observer's act of observation causes the wave function to collapse, manifesting as our perceived reality. All possibilities are unfolding in various parallel universes, with every one of them intertwined. We are simply one of these possibilities, and even our act of observation is just one among countless others. The power of observation. This implies a profound possibility. The observation of a single being is enough to influence every parallel universe. It reinforces the idea that our current reality is just one slice or perspective within a potentially much grander, multi-dimensional existence, and our limitations in perceiving it are simply a matter of the scale at which our consciousness and sensory systems currently operate. Conclusion. This journey through dimensions, from the familiar three spatial and one temporal, to the theoretical higher realms, reveals a fascinating interplay between our perception and the very fabric of existence. If, as we've explored, our experience is merely one zoom level within a multi-dimensional cosmos, where we can conceptually zoom in to unveil hidden compactified dimensions and zoom out to encompass broader perspectives, then this continuous nested hierarchy points towards a singular, all-encompassing reality. This ultimate reality, encompassing every zoom in and zoom out, could be interpreted as the divine, the infinite, the all-pervading God, not as an entity, but as the fundamental unifying principle of existence itself, potentially embodying characteristics of both animate and inanimate.